Alright, I think we're ready for a couple more examples here. Alright, let's jump into example D. D says to take the derivative of y equals 2 times the square root of x plus 5x to the third power minus 4. Now, I hope that we're starting to get the hang of noticing three different terms to take the derivative of here, right? Okay, I've got three separate terms, so take the derivative of each one individually. Now, I think 5x to the third and minus 4 might be okay for us to take the derivative of. But if I take a look at that square root of x power, or I mean that square root of x, that might give me a little bit of pause. But remember, we can change the root, or any root, in this case a square root, into a fractional exponent. Okay? So if I've got a square root of, let's just say, I don't remember the letters that they use. I think it's like m and n maybe. X to the n power, or m to the n power. We can rewrite that as the fractional exponent m over n. Okay? So whatever x is to the power here becomes the numerator of our exponent. And whatever root we're taking becomes the denominator. In fact, maybe I should, let's go back and let's do a different color for that so that stands out. Whatever root is there, that becomes the denominator. And so when we encounter one of these roots, I'm going to encourage you to not take the derivative first. I'm going to encourage you to rewrite that function of y first and then think about taking the derivative. Okay? So let's do that. All right, I'm going to rewrite this first. Okay, y equals, and I think we'll be good with 5x to the third and minus 4 out here, right? We don't need to rewrite that one. But let's focus in on rewriting 2 root x. Okay? 2, the coefficient out front, that's not going to change. So copy your coefficient down. And I'm going to write this in terms of x to a fractional power. So I'm going to start with my x. And if I look inside, the numerator of that, that's x to the first power inside that root. So it's x to the 1 over, and this is a square root. So it's a second root. We don't actually write it up there, but it is a square root. So this is going to be x to the 1/2 power. So take a look at that. Rewriting that root as a fractional exponent. We'll get some more practice with that, but that to me is the hardest part of this, okay? Because now I hope, that this looks like three terms that we can take the derivative of. So let's go ahead and do that now. Now we're ready. So y prime equals 1/2 times 2, and again, if you need to do that off to the side, please go ahead and do that off to the side. I still think that's 1. X to the, now negative 1/2 power, right? 1/2 minus 1, 1/2 minus 1, or 2 over 2. Oops, 2 over 2, yep. All right, and then let's do our power rule with 5x to the third. So what, 15, 5 times 3, x to the 3 minus 1 is 2 power. And then the derivative of the constant negative 4 is 0. So 2 terms in my derivative answer. All right, let's do example E. Gives us another practice at a root here, okay? And again, I'm seeing two things. I'm seeing x to the third underneath there, and I'm seeing a 7th root of x to the third. So I'm going to try and rewrite this again. So I'm not even going to take a derivative yet. So I'm just rewriting f of x equals 4x to the 5th plus 6, the coefficient stays 6, right? And this is going to be x to the 3 over 7 power minus 12. Okay? So again, not taking a derivative yet, just rewriting, so I'm not putting f prime anywhere or anything like that. Now that I've got it into my terms, right, I've got 1 term, 2 terms, 3 terms to take the derivative of. Now I'm ready to go, so now f of x becomes f prime of x, right, we're taking the derivative. And 5 times 4 is 20. X to the 5 minus 1 is 4th power. 3/7 times 6, I'm just going to write that out here. 18/7, oh man, so plus 18 over 7, x to the 3/7 minus 1, so 7/7, negative 4/7 maybe? And then the derivative of negative 12 is 0. That one's ugly. And you might be able to simplify some of these, but after taking the derivative with the power rule once, just leave it like this. It's perfectly fine. All right, so there was another practice with the root. I think we'll get some more practice as we go here. All right, let's take a look at f. F presents a little bit different challenge here, okay? And again, I hope we're seeing 1, 2, 3 different terms, so we'll be doing 3 different derivatives here inside of 1. And I do think that the 3x to the third and plus 3x on the end, I think those two, strike us as ones that we can be successful with. But having that x to the second power in the denominator of that second term might be a little bit tricky. Okay, this is where we need to lean on yet another power rule that maybe you remember from Algebra 2. Okay, the power rule for this one is, we'll just use a. So 1 over x to the a is x to the negative a. And so what we can do is we can take something like x to the second in the denominator, move it up to the numerator, and just make the negative, or the exponent negative. Now, it goes both ways, right? If we were to have something in the numerator and we wanted to move it to the denominator, we could just change the sign and do the same thing. So we can take these things and move them up or down to the top or bottom of our fraction. All we have to do is change the sign of that exponent. So again, I'm going to rewrite this one, okay? I'm going to rewrite this as y equals, I'm not taking a derivative yet, 3x to the third. And I'm going to put plus 3x out here. Rewriting this, there's a 5 here, right, that we're not really touching. So that's going to become that 5 that's negative is going to become our coefficient here. Excuse me. So that's going to become negative 5x to the negative second power. All right? This negative comes from the minus sign, right? The second negative in the exponent, that comes from moving x to the second power up to the numerator. Okay? Now, once we have that in the numerator, now it looks like something that we can use our power rule on. So let's go ahead and take our y prime here. 3 times 3 is 9. X to the 3 minus 1 is 2 power. Okay, now this becomes tricky, right? Negative 2 times negative 5 is positive 10. X to the negative third, right? Don't mess that up, minusing 1 there. And this is 3x to the first, so the derivative of 3x is just 3. Okay? All right, let's do one more example before turning you loose here, okay? I couldn't help myself here. Wrote a problem that we have to do 2 different transformations here for, okay? So the first one I'm going to focus in on is rewriting that x to the fifth in the numerator, okay? So let's get to that point. Let's go ahead and do that. So it's y equals, I'm going to keep 3/2 x to the 8th, right? I'm not changing that. And that highlighted yellow is the only thing that's moving, right? That 5 isn't being taken to the 5th power, right? If it was, we would have thrown it in parentheses. So I can rewrite that as plus 4/5 x to the negative 5th power. Okay? Now, I took that negative 5th power and didn't put it in the top part of the fraction. But, like, it's a multiplication problem, right? So we're good. All right, second thing, let's go ahead. This is x to the first square rooted, right? So we're going to rewrite this as minus x to the first power divided by square root. So negative 1/2, or negative x to the 1/2 power. And then plus 100. And by changing both of those around, I do think we're ready for a y prime. So let's y prime equals 3/2 times 8. A factor of 2 I can simplify out. So I think that gives me 12x to the 7th. Same thing with 4/5 here. I think 4/5 times negative 5. I think my factors of 5 will simplify out. So I'm left with minus 4x to the negative 6, right? Subtracting 1. 1/2 times -1 is -1/2 x to the -1/2 power. And then the derivative of 100 is 0. Any constant is 0. All right, so real tricksy on that one, right? We ended up having to take two of the terms to be able to rewrite them to feel comfortable using our power rule. Okay? So go ahead and finish this one up here. I think you've got, what is it, 6 more problems and a closure that you can take a peek at. All right, battle through those problems. Check some answers in the Go formative to see if you feel comfortable with those answers. And let me know if you have any questions.